Discussing the Python collections is added more support for data structure and algorithm. Like we already have list, tuple, and dictionary. It's a more different kind of dictionary, ordered dictionary, and the different types of counters. It automatically counts. So let's see. This is the collections, and these are all the data structures supported there. Name tuple. We see the counter. Counter it automatically count. Is there any collections? It automatically count number of reads, blues, and greens. We can see just we have to input from collections input counter. You see, and then and we pass on this list, and we'll see the value. It will count A is four types of A. 3A is here and 1 is here. B2 and C1. Here you can see another example of input counter. How many characters are there and which character counts how many times. Like L will be here 4 times. We can see it here. Then L is coming the most common. This is the one of the most interesting. It acts as a deque. It acts as a queue and stack both way. You can add on the extend or append operation on the right hand side and right hand side pop, and here is extend left, append left, and pop left. We see it here that we just create input collections and then we deque one collections with these values 1, 2, 3, and we print this and we see it here and deque it's 1, 2, 3. Then you can extend 4 on the right hand side. We'll see it here. Extend 4 by the append 4 and we can print it. Then append left on the left hand side we append 6. So this 6 is appended on the left hand side. The pop is the taking out from the right hand side and pop left for the left hand side. We can see it here. The 4 is taken away on the pop left, and if you go for pop left, and this is with the pop left operation, we take the 6. So remaining is 1, 2, 3 here. This is one interesting, making a stack with a deque. This is one of the most of an algorithm we have to create stack and queue, and we can with minimal programming we can make a stack. Like we create a deque, we can append on the right hand side, and my stack append A, my stack append B, my stack append C, and then print my stack. And on the left hand side we can see the, and the right hand side and the pop and pop. And let's see. So first is we create a stack with deque. It's a type of object A, B, C, and we pop from the C, B, and A. We can save this program. We can run it here. Jupyter Notebook. We can see it here. Run. We'll see the same result here. So Jupyter Notebook could help you without connecting to Colab. This is another interesting name tuple. Here the tuple, the index item, we can name it. Like we create a tuple from collections input name tuple, and we name the tuple X and Y. So where we create a point is a kind of a name tuple. Another instance B 12 and 24. I can call this a.x also. I can call it a.0 also. It's both way. So if we run this is a point and this is x3 and yx, and we can call it a.x or I can call it a with 0th or b. It is x or b 0th, and it will be the same values. One of the advantage of this name tuple, it is a lightweight class. So sometimes we do not have to create a class and create objects, so many code, and it is heavy. But we can create a tuple, and another advantage of tuple is immutable, and that is for like date of birth. It is generally not change, or first name, last name, it is not change. So these things we can create a tuple and we can name tuple. Like here we have the name tuple user1 Alice and the email, and user SRC and its email. We can see it here, and we can name this print user1. We can call it user1.email, or we can call it user1 with the index 2, because here the index is 0, here 1 is 2. So we can same email, we call it by email or 2. So this is lightweight and faster. This is ordered dictionary in Python. Advantage is that it will automatically ordered. It's ordered dictionary, and the we generally know the dictionary is unordered but hashable. Key item hashable, but here the ordered dictionary. The entry in the dictionary, it will be order wise. If you delete it, if you add that entry again, it will not go that position. It will go at the last position. You can see it here. This is the ordered dictionary. We give 1 to value 2 and 3, 4 to 4. And before deleting, you can see it here. This is 1, 1, 2, 2, 3, 4. Now I delete the order 3. So we delete this and let's see. Say 1, 2, 2, and D is deleted. Then add new item 3, but it will not delete its earlier position. It is added in the last position. So this is history will be kept here. That's why. Another good example is defaultdict. Defaultdict is if you don't have to supply key values. If it's not there, you can take the key value default. Like here, we are creating a defaultdict. Sometimes with the dictionary creation, if somebody do not give the key value, then that will be error. The error will come. The key error will come. But it is that we don't give the 0 here, but so that is a default 0 it is taken, and all the values are taken in this way. Another collection item is UserDict. UserDict is very useful. Sometimes we want to convert everything into lowercase, so we can create a lowercase so that anyway we supply this to. Another is UserDict. Is a wrapper class in Python collections, and we can method so that everything will be taken to lowercase here. Like here, first we give capital, second is D is capital, third, but it ignores. It goes everything by lower key. So key dot lower. So this is very advantageous in practical situation. So in case in fast and lowercase, that will equivalent. So this is a very good example. Another interesting collection is Chainmap. Chainmap is nothing but combining more than one dictionary together. Like here, this is one dictionary, but it actually give a combined view. It is not actually combining the two dictionaries. It's a combined view sort of thing to the Chainmap. Here we have a from collections like is a pizza, different type of pizza, farmhouse, cheesy, and drinks, Coca-Cola, Pepsi, Red Bull, side orders, this thing, and we can create a chain map. So it is nothing but a collection. So you can see it here.